I have posted the first homework set on Blackboard, and you can see that whenever you want. It's due, I think, in a week. I said I'll make it due in a week. And I'm just asking you to solve some very simple systems of equations. And one of them is written in terms of a model. And I'm asking you to solve the model. So you have to know what it means to solve a model. It means to find an expression for the endogenous variables in terms of something which is not endogenous to the model. You can do that. That's what I mean when I say solve. So we'll do some more examples of that today. And yeah, that's mostly what homework 1 is about. I also put some differentiation on there. So those of you who are a little rusty on your rules of differentiation, you should make sure you have something that can serve as a reference for you. You know, maybe you have an old calculus book somewhere that has differentiation rules in it. I'm going to tell you them in this class as well, so you'll have this review, what I think the important rules of differentiation are. And then really what you'll need practice with is applying those rules to take the first derivative of a function. So I ask you to do that in the first homework. So just over the next week, let's make sure everyone can do that. I also want to have a quiz. I want to have a quiz that's basically the same stuff. I will say last time on my first quiz, I included some things about logarithms and exponents, exponential functions, which I want to make sure you are comfortable with that as well. So that's what we'll do today and next Tuesday. So let's get started. Actually, it's a lot, I think. I want to share, let's see. This is where I was last class. Something about, let's just look at slideshow from current slide. This is, yeah, maybe I can have everyone there. I want to hammer down this idea. Hopefully everybody here who's listening understands what I mean with this first bullet point. System can be solved only if the number of equations is at least as large as the number of unknowns. And I put unknowns in quotation marks here because I'm not just talking about variables. I don't want you to like count the number of letters in an equation and say, oh, there's X, there's Y, there's Z. That's 3 variables. So I need 3 equations. Not that simple. What I'm talking about here is that the number of endogenous variables or unknown endogenous variables is the number of, you compare the number of equations to that number. So let me give you some examples of that. Also, I want you to be able to use the quadratic formula. It's just something, if I give you an equation and it turns out to be quadratic, I want you to be able to solve it. So let's do some examples of using the quadratic equation, or the quadratic formula, and solving some models. So actually, I think I only shared this for a little bit. Maybe I will, if I pin my video, does everyone see that? Big? On my screen, my camera here. Sorry, can you guys, is it appearing? Oh, so this is just on my computer? Okay, so how do I, maybe I need to actually share. Maybe I need to actually share my phone. Make a co-host.
We can see your phone, but I think we have to pin it ourselves.
You have to pin it, yeah.
Yeah.
I would like to share my screen here. I think I can do that. Let's see if this will work. What? Oh, I don't want to share my screen. I want to share my my camera. Sorry. I messed this up. Nope. Sorry, guys. Uh, what's the difference between share screen and share video, right? So what do you see?
We see your screen right now.
The screen of my phone. When I
Yeah.
want to show you what my phone is
But it was
broadcasting.
working when I just pinned your video.
Yeah.
What you were doing earlier.
Yeah. I guess that's what I have to do. Um, Spotlight video, would that do it? If I do spotlight video, now does everyone see it? At least bigger. I want you to see what I'm writing here larger. Is it?
Yeah. Yeah.
Oh, okay.
I see it.
Maybe that's better. Spotlight rather than pin. Okay. Let me give you an example of an equation that let's say it's x equals 2y plus 3. Here's an equation with two variables. If I asked you to solve this, you're like wondering, what does that even mean to solve this? It's already solved, isn't it? I found an expression for x. Well, it's sort of, it depends on what y is. Is y an unknown variable, an endogenous variable? If so, this is not enough information to solve the model. But if y, let's say, is exogenous, then it's already solved. Does that make sense? Excuse me. So, okay, so let's say it is specified that x and y are endogenous. Okay, then this isn't enough. You would need another piece of information like y equals x minus 1. Now is it enough to solve the model? Yes, because we have two equations for these two unknown endogenous variables. How would you go about doing this? I recommend using substitution. It's so easy, it's so simple. You've probably done it in high school many, many times. How do you substitute this in here? What should I do? I should take what I found for y and substitute it into there, right? So instead of x equals 2y, I have x equals 2. Well, what is y? Y is x minus 1 plus 3. You see how that's what I mean when I say substitution. What you're doing is substituting and eliminating y. This is the simplest method for solving a model. What would it actually be here? We have x equals 2x minus 2 plus 3. What's that equal to? 2x plus 1. Subtract x from both sides. Subtract 1 from both sides. I think, right, x equals negative 1. Good. Is that the answer? Did you guys get that answer? What about y? Go back and plug this in. Y equals x minus 1. So actually, y equals negative 2. Now I've solved the model. If I did it correctly, I've solved the model because I found numbers for x and y. What would this be if this were, I had some exogenous variables in there too. Let's say x and y are endogenous, and I'm going to make another variable, z is exogenous. You see the difference? My z isn't very good. I'm trying to make a capital Z. Sometimes I put that line in it to show that it's not the number 2. I'll put a little line on my capital Z's. Okay, so this now I'm sort of making it a little more interesting. There's still no economic context to this. I'm just doing math, just doing algebra. But hopefully, does anybody have any questions? Just can I continue? Can everyone see?
What is endogenous exactly mean?
Sure. Endogenous means, endo means inside or in the model. Exogenous means outside the model. So I haven't even told you what these models are. I'm just giving equations, but let's pretend there's an economic model here where X and Y are endogenous to the model. So what that means is that you care about those variables. They're in fact, the whole reason you write a model is to think about what happens to these endogenous variables. Then you might say, well, isn't that true for all variables? Don't we care about all variables? Why would we put them in the model if we don't care about them? Good question. Even if that isn't what you were about to ask, it's still a good question. And the answer is, sometimes there are variables that still affect what's happening in our situation. Like if you have demand for a good and it sort of matters what, it matters what the price of a substitute good is. Because if I'm talking about the demand for my good, and that's the thing I care about, it might be affected by the demand for a substitute, or the price of a substitute. And if you've studied economics, you have a very good intuition for why that's true. If the price of a substitute goes up, then I have more demand for my product. If the price of a substitute goes down, I'll have less demand for my product. Okay, so sometimes those variables need to be included in your equation because your equation is simply wrong without them. However, when you are trying to solve the model, you do not need to solve for any exogenous variables. In fact, the proper thing to do is simply leave them there. Treat them like constants. Okay? So you should, I haven't said what my equations are yet, but I have X, Y, and Z. You should treat X and Y as the thing that you're trying to solve for, and Z, just treat it like a constant. Okay? Kai, did I answer your question?
Yes.
Am I saying your name correctly?
Yeah. Hi.
Okay, cool. All right, so let me give you some equations with X, Y, and Z. First of all, how many equations will I need to give you? 1, 2, 3, how many will I need to give you?
Is it 3?
It's not 3. Thank you for the guess though, William. I appreciate, the fact that somebody gave an answer. It's not 3.
Is it 2?
It's just 2. So in this case, we don't need 3 equations. We only need 2. In fact, if we had a third equation, it's very possible we would come to some kind of contradiction, which makes it impossible to solve the model. So it's not only is it unnecessary to have a third equation, it may very well destroy the model by making it impossible to solve. Isn't that weird? Okay, and the reason is because Z is exogenous. We can't change Z. We can't say, oh, Z must be equal to such and such. If we do that, we're sort of manipulating something outside the model, and we shouldn't do that. So I want us all to start thinking about what it means to solve a model mathematically. It means to solve only for the endogenous variables and solve each one in terms of numbers or parameters or exogenous variables, but anything other than the endogenous variables. Okay, so I'm going to write just 2 equations here because we don't need a third. Here will be my equations. X plus Z equals 3y. X plus Z equals 3y. Okay? I'm going to write another one. I kind of want to give us a quadratic. I'll hold off on something that needs to be quadratic until later. 2z minus 3 equals x plus y. How about that? I'm trying to make this something that is not easy to solve, not obvious to solve. And if I were to ask you to solve this, you need to learn something, which is that, oh, what he really means is to solve for x equals something and solve for y equals something. And that something could involve z's, but it can't involve x's or y's. Okay? Anybody have any idea how to go about doing this?
Could we do substitution?
Yeah, great. Which one should Should we eliminate x or eliminate y? You can decide.
X.
Okay, let's eliminate x. Do you want to use the first equation to help solve for x, and then we can eliminate it? Right?
Yeah.
Okay, so what should I write? How should I rewrite this so that I solve for x?
X equals 3y minus c.
Right. This tells me that you can see the picture good too. It's coming in clearly, right? Great.
Yeah.
Okay, now we'll take Kai's suggestion. I think it was a good one, and use that to substitute this equation we just found, substitute it into this x. If we do that, we'll have eliminated x. That's our goal. Eliminate x. Not forever. We're not eliminating x forever, because at the end we'll come back and find what x is. But for now, eliminating x will help us solve for y. That's why we're doing it. Okay, so I'm going to do that myself. 2z minus 3 equals, now instead of x, I'll have 3y minus z plus y. Now I just use some algebra to simplify this. I'll add z to both sides and get 3z minus 3 equals, I have a 3y here and a y, I'll make that 4y. I'm going to divide both sides by 4 to get y equals, I'll just say 3z minus 3 over 4. Okay. Can I'm going to use the little notation here, and that is y star. Why do I make a little star there? It's because that's very commonly used notation to say, oh, I've solved for y in the model. Notice what I have something that says y equals, and there's no x's or y's over here. So it's like a solution, and therefore you can do a little star. It's almost like, it's like helpful to remind yourself that, oh, I'm done with y. Don't have to work anymore on y, at least I found y. Okay? And you realize that this, even though there's a z there, we should think of that as a solution because z is exogenous. Okay? If z were endogenous, I would look at this and say, no, you don't get full credit. You didn't solve for y. But because z is exogenous, I would say, great, you got the right answer. You're still not done because you should solve for x. How would I solve for x? Just plug it back in. Plug what you found for y back in. How about which one? How about the first one? I'm just gonna see if I have enough room to write it here with this y star in for this. I would get x plus z equals 3 times what I found for y, which is 3z minus 3 over 4. This is complicated. Is there enough room for me to write it here? I'm going to solve for x now on this side. What do I get? I'm going to leave that x plus z equals. I'm going to actually find out how much, I'm going to split this apart and multiply by 3. I'm actually going to get 9/4 z minus 9/4. Really, all I have to do now is subtract both sides by z and I'll get the answer. X star equals 9/4 minus 1 is actually 5/4 z minus 9/4. That's the answer. This and this. These two things here are the answer. You guys have any questions about how we did that? Just a few lines of algebra. But, oh my gosh, Kevin is stuck out? I thought I admitted him. Maybe he came and left and needed to be readmitted. If you guys, but I don't know if you can tell sometimes if somebody is waiting to be admitted and I don't notice it for some reason, please let me know. I'm sorry about that. Kevin, you here? I'm sorry if I didn't accept you to the room.
Yeah, it's no problem. No worries about it.
Okay. So what I just did is I gave you a model where there were two endogenous variables and there was one exogenous variable, and there were two equations. The model consists of these two equations, and I said solve it. What does it mean to solve it? It means to find what y star is in terms of exogenous variables, 3z minus 3 over 4, that's an answer. And then I solve for x in terms of exogenous variables. 5/4 z minus 9/4 is the answer. You guys think you could do something like that on a homework or a quiz? I think you could. Good. Oh, by the way, I think in the homework, I have not just two equations, but three. So for three equations, you want to see me do an example of that, or do you think you can do it on your own? So like I gave you an equation where x, y, and z, and all three are endogenous, and you have to try to do that. But the same method works. You can just, sorry, this is my bunch of scrap paper I have here. Let's maybe real quick. Does anybody want to see an example with three unknown variables and three? Maybe we should. Okay. And here's where I think I can give you something that involves the quadratic equation too. Just wait a second. I'm gonna give you this three equations, three unknowns. Before that, let's just give some practice with the quadratic equation and some like parameters in there, something unusual. So let's say if you have something like 2x squared minus 4ax plus 3a minus 2 equals 0. So now let's say this. X is the unknown, and a is a parameter. Sorry, I know I said I would use Greek letters, but I'll just use a for now, right? X is unknown, so solve for x. Okay, question or problem, solve for x. You guys think you could do this? I mean, what this means is solve for x, your answer is going to have a's in it because a is a parameter. You should think of a parameter just like an exogenous variable, something that's fixed, something that's like a constant, okay? Solve for x, what do? We use the quadratic equation. What does that mean? It means, maybe I shouldn't have said A, B, C. Hey, that's okay. It's going to be you'll have to see what to do to improvise when you have A that could mean two things, but it doesn't matter what variable we choose for the coefficients of this quadratic equation. What's important is to isolate what is the coefficient of the squared term, and here it's just 2, right? What is the coefficient of the linear term? It's actually negative 4a. And what is the constant term? What is the constant term here? Is it 3a? Is it minus 2?
Is it 3a minus 2?
It's both. Yeah. How come it's not very loud? Okay, I'll turn you up. It's both. Yeah. 3a minus 2 is the constant term. The constant term. Okay, so how do we solve for x? Use this formula which says x equals negative b plus or minus b squared minus 4ac over 2a. So we have to now realize what a, b, and c in this formula refer to. A refers to this, the coefficient on the squared term. B refers to this, the coefficient on the linear term. And C refers to this, the constant term. Okay? If we know this formula, we can just plug it in and get the answer. Let's do that. X equals negative b. Well, what is negative b? B is negative 4 capital A, so it's actually 4a. Right? The negative of a negative is a positive, so it's actually 4a plus or minus the square root of. b squared. What is b squared? Well, if b is negative 4a, then b squared is now 16a squared. Minus 4 times a times c. Okay, well, a is 2, so 4 times a is 8. So we actually have 8 times this constant term, and I'm subtracting that. I'm subtracting 8 times this constant, so it's minus, I'm just going to go ahead and write it out, 24a, and then minus 8 times minus 2 is actually positive 16. All that over 2a. A is 2, so it's 4. I think that's good. I think that's an answer. Done. Question, solve for x. Answer. There you go. You see how actually it doesn't involve much thinking or algebra at all. Most of the time here, it just involves using the formula. So I just want to be able to give you guys quadratic stuff and have you be able to solve it. You guys have any questions about how I got this answer from this problem? Hope I didn't make any mistakes. Maybe I should have slowed down that step of 4ac. It went pretty quickly about writing 4ac. If you wanted an intermediate step, it would be this: negative 4 times a times c. That's how I got this part here, negative 24a plus 16. Okay, no questions? All right, now let's give you something that's like the homework. I'll show you the homework maybe right now. Where is it? It's gone. Yeah. Here's your homework. Econ 403, homework set 1. Solve the following system of equations. You know, I wish I had, okay, so 3 has this thing about exogenous or endogenous, but 1 and 2 don't. 1 and 2 are just models. What am I asking you to do in homework set 1? Solve for one variable in terms of another. Use substitution, okay? So let me give you one that's not exactly this, but similar to this. With an x, a y, and a z. And I want to include a squared term in there too, so that you have to use quadratic equation. So let me think of something that's similar. How about x plus y, instead of equaling 2, it equals 4. How about instead of 3x, we have 2x minus 6z equals 2. And maybe another y squared plus z equals 10. I don't know. I'm just making up these numbers. Okay, so I'm giving you something that's pretty similar to the homework right now. Hope that's okay. Hope I haven't made this class too easy. Maybe well, let's just go through an example. Maybe I know what I can do. Well, that's fine. I don't care that this is the same as this is part of being in Zoom is that I want to be available to help you, and sometimes I'm not going to be quite as available. Therefore, what I do provide to you in class content has to be pretty descriptive. Okay, solve this for x and y. So the question is, solve for x, y, and z. They're all endogenous. Nothing's exogenous here. Solve for x, y, and z. What do you think is the first thing we should do in this example? We should try to solve for one of the variables so we can eliminate it. Which one should we pick? Which one looks like an easy one to eliminate?
First one,
Yeah, which variable, x or y?
X.
You know what? I like x as well. You know why? Because it only appears one other place. So if we solve for x and then eliminate x, that'll be easy to do. Let's do that. So once again, I will take Kai's suggestion and solve this for x and get x equals 4 minus y, isn't it? We're not done, but we at least have a way to eliminate x now and substitute it. There's only one other place where x exists, and that's here. So we can take this and plug that into there and get what? 2 times x, well, it's no longer x, it's 4 minus y, minus 6z equals 2. Okay. I want to clean this up a little bit. I actually get 8 minus 2y minus 6z equals 2. I think this will be cleaner if I make everything positive. So I'm going to subtract 2 from both sides and get 6. I'm going to add, you know what, I'll leave one of them. How about? I'm going to look ahead and say, which one of these am I going to want to solve for? It's z. I'm going to want to solve for z. I think just so that way I don't have to square it. If I solve for y, then I'd have to square it, and that's a little bit extra work. I'd rather not. So I'm going to solve for z. So 6, I'll leave the minus 2y over here, but I'll add 6z to both sides and get this. And in fact, now I could divide both by 6. That gets divided by 6. That's just z. You guys see what I did? I took Kai's suggestion, eliminated x, then I just started substituting in, and then I started thinking ahead, well, what's probably the next thing I'm going to eliminate? And I think the answer was z. So then I just went ahead and did it, solve for z. Z equals 6 minus 2y over 6. In other words, maybe I can simplify that a little bit. I'm going to go to the left here to simplify it and say 1 minus, what's 2/6? It's 1/3. I'll just say 1 minus y over 3. Kind of the easiest way to say it. Wouldn't you agree? So does everyone follow me? Notice I have not put any stars here. And that's correct. If I put a star here, that would be wrong. At least not using the notation the way I intend. Because a star means you're not solving in terms of another unknown variable. You've actually solved it. So don't put a star there because we're still in the process of solving. Here, let me leave this here and maybe I can put side by side. Oh yeah, side by side's better. Sorry, these have all been ripped out of a notebook, but here we go. So where are we now? We have, I'm going to rewrite what I've just found. Z equals, oh, it's way up here, you can't see it. Z equals 1 minus y over 3. I want to substitute that into this final equation, the one with the square in it. Y squared plus z equals 10. I'm going to rewrite that here. Y squared plus z equals 10. See what I've done here? I've rewritten the last equation up here, and I have also rewritten what we found by eliminating variables there. Okay, so now we have to eliminate. We need to substitute one more time, and we'll get it. What do we get? Y squared, right now I'm going to take this and substitute that in for z. Okay, what do I get for y squared? Plus y squared plus z. Well, z is actually 1 minus y over 3 equals 10. Remember now, I just taught you the quadratic formula, so let's use it. And let's put this in a way that makes it easier to tell what the coefficients are, so we can use that quadratic formula, the one I just wrote right here. This quadratic formula, we're going to use that now. What do we get? I'm sorry, for some of you, this is probably like really easy. You're wondering, why am I spending so much time doing this? I think let's be honest. This is a review. This might be something that you've learned in high school or in earlier, earlier in your life. It doesn't mean it's not good to review it every once in a while, because sometimes people, it's like, oh, it's been so many years, I forgot even how to do that. I'm just showing you how to do that. And I'm asking you to do it on your homework as well. Okay. So we got it in something that's ready. Notice I subtracted 10 from both sides. That's where that minus 9 comes from. Now I'm ready to use the quadratic formula. Remember, it was here, except instead of x equals, I have y equals. Y equals negative b. What is b? B is negative 1/3. So negative 1/3 is actually positive 1/3, plus or minus b squared. Oh, geez. I think I'm going to have an imaginary number here. Oh, no, I'm not. Oh, I'm not, because I have a -9. I'll be fine. I'm good. Phew. Okay. B squared, remember B is -1/3, so that squared is 1/9. Right? -1/3 squared is 1/9. And now I have -4. I'll write this out this time. -4 times A is 1, times C is -9. All of that over 2A. A is 1, so that's 2. Let me try to simplify that. Y equals. I'm going to move this to, separate this and just write 1/6 plus or minus 1/2 times the square root of what? Some weird number in here. 1/9 minus, but there's a negative here, so that becomes positive 36. This number is going to be very close to 6 because the square root of 36 is 6, but unfortunately there's that 1/9 in there that's going to make it, wait a second. This actually will be, no, it won't. It won't be. It'll be irrational. It's going to be irrational. It's almost rational, but it's not. But that's okay. If I give you a homework problem and you're like, wait, this can't be right because the square root doesn't work. That's the wrong way to think about it. This is college, so I'm allowed to give you questions that have irrational answers, okay? Or, you know, I have some people who say, I thought it had to be a whole number, so even though my answer was 3.5, I thought it was wrong. No, you can give me decimals and fractions and even irrational numbers as your answer. And for technical reasons, using Blackboard, they have a way for you to, some answers will require a number. And in those cases, actually, you won't be able to give irrational answers. But if ever it is irrational or something like that on a quiz, I will tell you, just give it accurate to the 10th place or something. And you may have to use a calculator to see. If it's something like the square root of 5, you don't know what the square root of 5 is, have a calculator. You know, Google works as a calculator if you don't have one. And just give it to me accurate to how many places I say. And actually, Blackboard's pretty good. It says, I can input the range. I can give the right answer and I could say the range. And if you give me an answer anywhere in that range, it'll count it as correct. Okay. But for this, which we're just working out on pencil and paper, it shouldn't bother us that we're going to have an irrational answer here. What do we have? Y equals 1/6 plus or minus 1/2 times. I don't know how I want to write this. I'm trying to simplify this, but unfortunately now I have to multiply 36 times 9 in my head, and I will get, is it 324? Plus 1 becomes 325. Or 30, oh, I'm sorry, over 9. That's what I got in my head. I think that's right. Right. 270 plus 54 is 324 plus 1 is 325. Okay. So can I put a star here? Well, actually, this has, you know, I should have, I think I made a mistake here in that I didn't give you this advice in the homework that when you have a quadratic equation, there's more than one answer. There's a plus and a minus, and they're both valid answers. So what I would do here is treat them both as potential solutions to this problem, okay? And therefore, there's going to be two solutions. There's going to be two sets of solutions. There's going to be an X star, Y star, Z star that corresponds to the plus, and there's going to be a separate X star, Y star, Z star that corresponds to the minus. And the most complete way to answer this question would be to give me both the positive, you know, both sets of answers. So, you know what I think I'm going to do is use Google to get a decimal approximation, and then we'll just pretend like now we're just getting close enough to this. I'm going to look for the square root of 325 over 9 and get 6.009. That's like 6.01. I'm going to divide that by 2. And then I'm going to assume it's positive and add 1/6 to it. And I get 3.17. I'm just going to say y star equals 3.17. That's one answer. The other one is 1/6 minus 3.0. The other one is y star equals negative 2.84. Okay. I'm sorry. What are you seeing now? Are you seeing my spotlighted video? You are seeing my spotlighted video. I think I got those two answers. They're decimal approximations, but I got this square root and I plugged it into Google to give me at least something accurate to the 100th place. And I'm just going to go with that. But so now actually what I'm going to have are two sets of solutions. For this y star, I'm going to get an answer for x. And that, of course, depends on the original problem. Where is it? Here. Let's use this. X equals 4 minus y. So I'll take 4 minus each of these y's and get an answer. In fact, I think I can do that in my head. Here, x star equals 4 minus 3.17. That's 0.83. Sorry, I did that in my head, but use a calculator if you'd like. Now, how about for this one? X star equals 4 minus that, which is negative 6.84. I'm using what I knew, this relationship between x and y, which we found given our problem. I'm using that to solve for x star given each y star. Okay. What about z? Z might be a little trickier. What should I use for z? I'll use this, what we found here. Z, it's actually written at the top. This one right here, I'll use this for z. Z equals 1 minus y over 3. Okay? That's how I'll find my z star. I will not do this one in my head. I will use Google or a calculator if you have it. But it's for the first z, I'm going to say 1 minus 3.17 over 3. Oops, I didn't. Yeah, I get z equals negative 0.06. And for the other z, I'm going to get 1 minus a negative 2.84. So that's 1 plus 2.84 over 3. What do I get for that? 1.95. Okay. That's it. These are the answers. Can you see? Oops, I'm a little off the screen. I got these answers by taking the 3 equations and systematically solving for one of the variables and eliminating it and substituting it and eliminating it till I get down to 2 variables, then do it again. Substitute, eliminate till you get down to 1. Once you get down to 1, you've actually got a solution. And then you can go backwards to get the second and the third, the things that you eliminated, and get this pair of solutions here. So hopefully you can do something like that on your homework. Remember
sorry, the 6.84 negative, I missed that. I was getting positive for some reason.
Oh, did I do something wrong here?
Yeah, wouldn't that be positive 6.84?
I think you're right. Sorry about that, guys. Because what is it? It's 4 minus y. y is negative, so 4 minus negative 2. Sorry. Thank you. Thank you for the correction. X star should be positive 6.84 in that case. I don't know why I did that. Just put the wrong sign. I don't think that affects z because I used this y to get this z. I think the z should still be okay. Unless I made another mistake, I think the z should be fine. So hopefully this is very similar to the problem I asked you to do on your homework, and you'll be able to do that.
Can you remind us how you got the 325 over 9 and the y equals?
I just put these two numbers over a common denominator. So like I said, 36 over 9, did I do this right? Oh yeah, I took 36 times 9 and I got 324. So I got like 324 over 9. And then I added 1 over 9 and got 325 over 9.
Okay, thank you.
Yeah. But if you're like just plugging this into a calculator, you could have plugged it directly from here. It just would have been a lot of lines and of numbers you had to punch in your calculator. Let's go on about more models and more equations and things like that. Let me share this screen. Okay. Here's another. Now here's an economic example, and that is solving for a general equilibrium when you may be very used to solving for price when you have just one good, price and quantity. But here's an example where there are two goods. There isn't just one good, there are two goods, and the quantity supplied and the quantity demanded for each good okay, let me rephrase that. The quantity demanded for each good depends on the price of both goods. Okay, so that's why instead of a partial equilibrium, which is kind of like when you just look at the market for one good in isolation, it's not total general equilibrium, but it's like, assume there's more than one good, there's two goods, and the demand for one good here, Q, you see my cursor, I think, Q equals D1, is a function not just of the price of good one, that's what P1 means, but it's also a function of the price of good two. So demand for one depends on the price of good two. And similarly, the demand for good two depends on the price of good one. So can anybody use some economic intuition and tell me, are these good substitutes or complements based on that? Use some micro economics. So the demand for good one has a plus P2 on it. That means when the price of good two goes up, there's more demand for good one. What does that mean?
They're substitutes?
They are substitutes. Thank you. Because it's like Coke and Pepsi. If the price of Pepsi goes up, you say, okay, now I'm going to buy more Coke because I'm just going to switch. And the same is true for good two. The fact that there's a plus P1 in here, it's like saying these goods are substitutes. If the price of good one goes up, I'm going to switch and buy more good two. So here's an example. Here's an economic example where it's just like you wouldn't have had to think of this as a model in any of your previous classes. You would just think of this as, okay, we're just solving for the price of these two goods, and you would just plug it in and probably be done with it. But now I want us to think of this. Hey, this is like a model. This is a model where there are how many variables? There could actually be 6 variables here. P1, P2, QS1, QS2, QD1, QD2. You could think of it this way. It's up to you as the modeler, really, to say, are there 6 variables here? Or maybe are there only 4 variables? What do you guys think? Which I'm curious how you would attack a problem like this. Would you think that this is a problem with 6 variables or 4? Here's another question. Are QS1 and QD1 really different variables here? S means supply, D means demand.
Not really, because technically, isn't it going to be the equilibrium quantity for both?
Yes, right? So this is Amina talking?
Yeah.
Okay, yeah. I mostly agree with what Amina just said, at least for practical purposes. For practical purposes, we don't need to think of QS1 and QD1 as different variables. Remember what that means. QS1 is the quantity supplied of good 1. QD1 is the quantity demanded of good 1. If we in our heads already jump ahead to the equilibrium of these markets, it says those two are going to be equal to each other. That's what I've written here in these two bottom bullet points. And then I'm sort of leading you to the answer here to say, instead of even thinking of those as two separate variables, let's just combine them right off the bat. Combine them and say that's Q1. And I just want a moment of caution. The only reason we can do that is because we're solving for equilibrium. It's like in equilibrium, they have to be the same. So let's just say those two variables are the same. We'll call it Q1. And for Q2, let's just say those two variables are the same and call it Q2. Now we have 4 variables. And I'm asking you to find Q1, Q2, P1, and P2. Once again, I think this is similar to a homework problem. How would we do this? Same method. Eliminate variables. Just keep eliminating them using substitution until you're down to 1. And then put a star on that one and say, okay, we found this one with a star. Now let's go back and find the other star variables. You guys want to try this, or just see me do it? Or I have the answer on the next slide. I can just go directly to how I would answer it on the next slide. If you want me to do that? Or do you want to see it written out on paper? You want to see it on the PowerPoint slide or on my paper and pencil?
I say paper.
You say paper and pencil?
Yeah.
Okay. It's going to take a little more time, but hey, what the heck? You're the boss. I'm working for you now. So you want to see paper and pencil? I'll show you paper and pencil. Okay. That means I'm going to have to write this down. By the way, when I write this down, I'm going to directly write it as Q1, Q2, P1, P2. I'm not going to write the S1 and the D1, anything like that. Okay? So here's what I'm writing down. Q1 equals -2 plus 3 P1. Q2 equals -1 plus 2 P2. I'm also writing Q1 equals 10 minus 2 P1 minus P2. I'm also writing Q2 equals 15 plus P1 minus P2. Okay, stop share. And I'm gonna actually, oh, it's already spotlighted. You guys are seeing this camera here spotlighted. Okay, so I've just written down the 4 equations, and there's 4 unknowns here. Q1, Q2, P1, P2, 4 unknowns. So let's think of, first question is, what should we try to eliminate? What's the easiest thing to eliminate? I would say both Q1 and Q2 are going to be pretty easy to eliminate, aren't they? I can see right off the bat how to eliminate Q1. Just set, plug this into there or this into there. You're basically setting the right-hand sides of these two equations equal to each other, and that will eliminate Q1, right? Okay, so let's do that. I'm going to write it as a new equation. This one and this one written together down here. I get -2 plus 3P1. This is all stuff I would do on the whiteboard if we had a whiteboard. We were in the same room together. 2 minus 2P1 minus P2. Okay, let me simplify that a little bit. Add 2 to both sides. Add 2P1 to both sides. And I'll leave this P2 here. Good. Maybe I should go a step further and say solve for P2. I'm going to add P2 to both sides. P2 equals 12 minus 5 P1. So I've actually, not only have I eliminated Q1, now I've actually solved for P2 in terms of P1. What I'm going to need to do now is the same thing, but with these two. So these two together went there. Now I want these two together down here. The right-hand side of this is negative 1 plus 2P2 equals 15 plus P1 minus P2. I've got plenty of pencils. They're a lot cheaper than whiteboard markers too. Okay, let's simplify this. You know what I'm going to do? I'm going to try to solve this for P2. But that will make it really easy to plug it into there. Add 1 to both sides. Subtract. Oh, what do we got? We got P2s. So I'll add P2s to both sides and get 3P2. I'll leave this P1 here. I think that's good. Just doing algebra here to simplify. Now what I want to do, I actually would rather solve for P2. So let me divide both sides by 3 and get 16 over 3 plus P1 over 3. You see what I've done? Using at this step, I eliminated Q1. At this step, I have eliminated Q2. So the only thing left are now P1 and P2. And I've got this equation and this equation. Now I'm going to eliminate P2. Eliminate Q1, eliminate Q2. Now I'm going to eliminate P2. And the only thing left will be P1. And then we'll be good. So I'll take the right-hand side of this equation and the right-hand side of this equation and make a new equation that is 12 minus 5P1 equals 16 thirds plus P1 over 3. Okay. And how am I doing on time? 1:32. What do we go to? 1:45? Okay. What do I need to do now? How about this is actually equal to 5 1/3. Can I subtract 16 thirds from both sides? This is actually 36 thirds, right? 36 minus 16 thirds is 20 thirds. Now if I add 5P1 to both sides, 5 plus 1/3, 5 is actually 15 thirds, plus 1/3 is 16 thirds P1. Hopefully I've done this right. Now I want to multiply both sides by 3/16, essentially, to get 20 thirds times 3/16 equals P1. What do I get here? Cancel, cancel, divide by 4. I get 4. I get 5/4. Hope that's right. If it is right, I should put a little star here to indicate I've solved the model. I'm gonna peek ahead at my answers to see if I think that's right. Uh-oh. It's not what I got here. Dang it. Did I change the did I change something? Let me see. So I still have P2 equals 16 thirds plus P1 over 3. That one I have. I have very, very similar thing here. Oh, you know what I have is I have a negative sign here. What do you guys think? Where have I made a mistake? I have a very similar thing, but I just have a negative sign right here in on my slides. So It's this equation that's in doubt. Negative 2 plus 3p1 equals 10 minus 2p1. Wait, did I write that down wrong? Did I write that down wrong? This is why. This should have been plus p2. Sorry, guys. So much to write down. I think made a transcription error. I believe this right here, the equation should have been 10 minus 2p1 plus 2p2 plus p2. And that changes this. Changes this to say p2 now is equal to not 12 minus 5p2, but the opposite of that, which is 5p1 minus 12. That's what it should be. Sorry, guys, this is wrong. And now if I have 5p1 minus 12, so that's where the negative comes in here. And so now I have negative 36 thirds. I should actually be adding 36 thirds to both sides. Let me just do it on a new piece of paper because sorry, I apologize. Everything here is right given the transcription error, but I made a transcription error. So let me rewrite this as 5p1 minus 12 equals 16 over thirds plus p1 over 3. Thirds plus p1 over 3. Now I think I'm better. 36 plus 16 is 52 thirds. And now I subtract p1 over 3 from both sides. I get 15 minus 1 is 14 thirds p1. That's what I got. So once you get this negative sign in here, I think this is what you should get. And now multiply both sides by 3/14, you get p1 equals 52 over 14. That is actually what I have on the slides. Okay. What was that? That darn sign right there messed everything up. So once you get P1, now I can put a little star here. That's the correct P1. P1 star should be equal to 52 over 14. You guys have any questions? I mean, given that I made the error in writing it down, once the error is corrected, this method does work. You keep eliminating things until you get down to P1, and you should get the answer 52 or 14. I see some of you are sort of working it out on your own, maybe, and you're also getting 52, 14. Good. Of course, the answer, that's not the answer because it also asks you to find, well, what's P2? I would use whichever one of these you feel like. How about this one? P2 equals 5p1 minus 12, so it equals 5 times 52 over 14 minus 12. Oh, that's gonna be ugly. I don't even know what that is. I'd use Google or any calculator. 5 equals 5 times 52 over 14 minus 12.
When we put answers, do you want us to simplify it, like 52 over 14, or does it matter?
Why do I have this 5 here? No, you can leave it as a fraction. Yeah, sorry. You can leave it as a fraction. I still haven't got the right answer here. 6, I don't even know. It's a 6.57 for P2. You know, you can go back and solve for Q1 and Q2 as well. I don't think that's that important. I mean, it is. If I ask you for the answers, you should give me all the answers. But yeah, if you give this to me as a fraction or a decimal, I don't care. And of course, on Blackboard, I will tell you what accuracy. Say, please give accurate to the 10th or the 100th, and I'll make sure it gives you credit for anything that's within that range. I think Blackboard will want decimals now that I think about it. So if it's okay, I will resolve this right now. For homeworks, you are going to write it on a piece of paper, take a picture of it, or you do word processing and upload it to Blackboard, and that's how we'll be grading you based on what you submit. And for that, it can be fractions or decimals, or square root signs. That's okay. But for Blackboard, entering on a quiz or a test, quizzes and tests, those I think you will need to use decimals. Does that make sense? Because I'm just not even sure if it'll accept the fraction in the right way. Okay, so let's, where are we here for this economic modeling part? This is what I think the answer is. You get this 52/14. And then you plug that back into the other equations to get values for P2, Q1, and Q2. You guys have any questions about that? We only have a few minutes left, but let me just bring up this national income model because that's also on your homework. The national income model is a macroeconomic simplification of a bunch of different stuff. And it says the total output of our economy as measured in dollars of goods and services produced is equal to C plus I plus G. And that is, Y is total output, C is consumption, I is investment. And here investment doesn't mean like dollars that you put in your bank. It means the type of investment that's a business might do to try to grow. It might invest in its business, might buy things to invest in its business. And G is government spending. So this is really just an equation, Y equals C plus I plus G, that talks about what are all the ways that our economy produces output. And now the question is, okay, let's think of that as a model, just like the demand was a model. If this is a model, what's endogenous and what's exogenous? And I would argue it's up to the person who does the modeling. The person who's looking at this, it really depends on what they're interested in. They may mostly just be interested in Y, or Y and C, or Y and C and I. You can think of the same model as doing different things depending on which variables are endogenous and which are exogenous. Okay, so I'm really running low on time. Ooh, I think I've run out of time. So next class, we will look at this model and say, what can we do to solve it? Is it already solved? No. Unless Y is the only exogenous variable, then I suppose it's solved. If you know C and I and G, then Y is the only unknown, and then that's a solution. But it becomes more interesting when there's at least two unknown variables, and we'll look at that. You can take a look at the homework if you want to see what's coming ahead. Maybe get started on it so you don't have to do it all at the end. And I don't know. You guys have any questions? I'm gonna stop sharing. This is all available on Blackboard too, as slides. I may have to go a little bit faster. I find myself going slowly with this method of writing stuff